Global framing procedure. In today's video we will cover generic framing procedure for mapping 10G LAN PHY L2 transport data over OTNs. So why do we need GFP? Why it has came into picture? What was the requirement? So there is a scenario where traffic growth continuously increased in the LAN network because enterprises started using, and LAN was not only subjected to its one location, the very definition, rather than it was a closed LAN, and there is a different location being involved because the same enterprise is having many offices, and they wanted to have seamless communication between their offices, similar to anybody sitting at the same location. So LAN continuously taken a big growth, and at the same time, when traffic is growing, then there was another technology came in picture after SDH, which is OTN, which has taken care of the big capacity requirements. So that is OTN. So the problem was that this OTN was developed to overcome the problems, or you can say the requirements of capacity, which was not fulfilled by the earlier famous technology SDH. So as and when the requirement goes on, new technology comes, and OTN came in picture as the successor of SDH technology. So the basic inclusion of the requirement happened for SDH technology, and by having this kind of requirement, there was a problem that LAN technology, which works on the Ethernet, mostly having slightly different data rates than the corresponding data rates of transport technology, which is OTN. So OTN line rates are different, and the LAN which is growing for enterprise network was different. So there is always a problem of mapping the one technology to other technology, and in this case the problem was the data rate of the transport was lesser. So 10G LAN PHY signal was 10.3 Gbps, while the 10G OTU signal was 9.995. means that OPU is the portion of the OTU, means OTN signal data rate, where you can put the data of client. So this is less than the required data to be transported for 10G LAN PHY. And there was similar other technologies which faced the similar issues of not matching the data rates. So there are two solutions to overcome such issues. Either you increase the rate of OTN frame, means you reduce the timing so that it runs faster, and then you get the required data rate for any technology which is to be transported using this. And then other one was to have another technology which can do some work in the client signal before it's getting transported to the OTN network. So the both solutions were available, because we know in OTN the frame is the same, and the speeds are achieved by using different timing of sending that same frame. So that is okay to be done, but the problem is that for every type of technology to be transported, we may need a different type of clock rate. So different speeds to send the data, which is not a good idea. So we can do overclocking. Overclocking means sending faster. So other one has to be that is the best solution, and that's where this generic framing procedure was developed, which would take care of those requirement of mapping one type of technology to transport like technology. So GFP is not only for one client of signal, one type of client signal to be transported only on one type of technology, but it can transport like many type, almost all type of technology signals over almost all transport technology. So like SD, it can transmit like 10G LAN into SDH, or 10G LAN into OTN, and other FICON or other type of signals to OTN technology. So how it actually works? So in GFP, approach is taken like the 10G LAN PHY signal, which is 10.3 gigabit per second rate, that is intelligently segmented in order to map correctly to the standard OTN rate, which is in this case is OTU2, which is 10.7 gigabit per second. So while in the mapping process, some of the overhead bytes have been curtailed, and like in Ethernet there are preamble and certain control byte, and there is in Ethernet technology after any frame there is a gap. So that has been intelligently discarded or taken care by this GFP framing procedure, and then some is reduced. So if some byte or bits are not required to be sent, where the work is duplicate, they are curtailed, they are removed, and then the same bit rate is achieved and mapping is done. And in case it is not only that in GFP the changes or the filter is done on the signals which is required to be mapped, but into the OTN frame itself, where we see in OTN, in OPU layer, there are bytes which is not required to be used, or there are reserve bytes. So in case of GFP, like in OTN frame, I will go to the next slide to show the OTN frame. So in OPU overhead there are bytes which can be used. So in 16th column or 4 bytes, so or 16 column 1 2 3 4 byte, and in 15 column 3 reserve byte. So total 7 bytes can be used to send the payload data itself. So it is taking the advantage of the unused or not required overhead bytes to send the data payload itself. So this is the modification achieved by GFP framing. So then using this type of mapping, the speed matching is achieved, and then in terms of identification, there is a code that is a proprietary code for GFP that is set to identify the payload type. So then this becomes the payload type for the transport section. So here is the frame, just for reference, that the frame size, this frame size determines how much is the speed some technology is going to achieve. And in OTN frame, this is 4080 into 4 byte. This is the size of the frame, which goes into different set of timing to achieve the speed. So for 10G it is around 12.1 microsecond, and that's how we standard speed is OTU where that is around 10.7 Gbps. For reference, I have given the Ethernet frame here I am showing. So Ethernet frame, the frame bytes, that is the payload byte, that is a range, it is not fixed. And there is a preamble, then SFD, then that is the gap I was talking about. There is a gap after every frame of around 9.6 microsecond. And then there are bytes, control bytes, other than the source and destination bytes. There are control bytes in this frame. So by playing with these overhead bytes of Ethernet frame in this case, or any other technology frame, and the OPU bytes, OPU overhead bytes, the GFP take the advantage and do the seamless type of mapping from one technology to another technology. So the problem was resolved without doing much changes in the transport technology. So there is intermediate framing. So Ethernet is also a frame. The Ethernet frames comes in, and there is a destination frame, is OTN frame. In between there is a framing procedure used, that is GFP. So where it is used, that the answer is I have already told that GFP can be used almost for every technology to every technology. So client signals like IP and Ethernet MAC or fiber channel or ESCON or FICON, and that can be mapped to transport network. So you can say transport famous technology, SONET in America, SDH in the rest of the world, and then on the OTN, which is available everywhere. And this GFP also support those major requirement of transport control and protection or resiliency, things like it is a point to point and it can work in ringed. So this mapping of one frame type to another frame type, there are type of mapping in the GFP also. So there are two type, that is, one is frame mapped, another one is transparent mapped. So in frame mapped mode, the entire client frame, whatever frame comes one time, that is simply mapped to a GFP frame. So just without waiting, like one frame mapped to one frame, one GFP frame, and then it goes as a single client frame that is mapped into single GFP frame. So Ethernet frame into mapped into the GFP frame. So one-to-one kind of a framing. So frame mapped one-to-one. Another mapping type is transparently mapped. So this is mapped in terms of kind of block code taken from the client frame, and then it is mapped to a certain different size of the frame. So 8 by 10 byte codes are grouped, then mapped into 64 byte, 65 byte. So the mapping and then overall frame remains the same as such, but in terms of this, before sending the GFP frame, we need to wait for the entire client frame. In this case, if some block has come, just simply they are mapped. So the mapping happens faster in the transparent mapping. In the frame mapping, so that is called a GFP-F, and the second type is called a GFP-T. So in GFP-T type, more efficiency in terms of bandwidth is achieved because it does not wait. Delay is less in transparent mapping. Thank you. That's all.